We have seen that the pressure in a liquid increases with depth. This ultimately is due to the additional force of gravity from the mass of the liquid above. We can calculate the change in pressure with depth as long as we know the density of the liquid. Here are the densities for some solids, liquids, and gases. The animations show that the density depend on how closely spaced the atoms or molecules are in the material. In solids, the particles are so close together that they're essentially locked in place. Densities of solids typically range between thousands to tens of thousands of kilograms per cubic meter. The densities of liquids tend to be somewhat less than solids. In part, this is because the particles are slightly further apart, giving them enough room to flow past each other. Of course, the mass of the atoms also factors into density. For example, mercury atoms have a large mass, making them an especially dense liquid. In gases, the spacing between particles is quite a bit greater. The density of gases tends to be much less than that of solids and liquids, on the order of about a kilogram per cubic meter. Because of this, we generally take the pressure in a gas to be constant, regardless of depth. In fact, the pressure does vary, but over much larger length scales. We will take a look at this in the next module. One other distinction between liquids and gases is that there is so much space between the particles in a gas that it's fairly easy to change the density of a gas by changing its volume. We say that gases are compressible. Liquids, on the other hand, are said to be incompressible. Changing the volume of a liquid requires such a substantial amount of compressive force that for all intents and purposes, the volume stays fixed, and so the density is a constant.